Well, Sunny Log. Happy New Year, everyone. It's me, Jeffrey, from Quintlight. I am here in the new year to talk about an interesting prototyping process that we went through recently. I did this over the past month or so, really a few weeks. Basically, we are about to introduce a whole bunch of new products. They are pendant lights, so hanging from above, and they are kind of, obviously for people who have the need for pendant lights. So I want to talk about the process of prototyping in 3D design and 3D printing specifically. And then even more specifically in this highly advanced 3D printing that we're doing here at Quintessence that involves direct G-code programming using Grasshopper. So basically, we can see this piece right here is very interesting. It's a lattice, like everything we make here. It looks okay, but if you look close up, it actually has some problems. So basically, you can see there's a lot of what we call stringing, which is like the little stringy bits that go in between these pillars and stuff. And then like a lot of that's the main problem. And then like a little bit of like surface problem, like defects and stuff. But mostly the stringing is what we're concerned with here. So basically, I went on because I can't really sell this. I don't want to give you a product that has all these strings in it. And when you put light through it, of course, you can see all those strings because the light is shining right through them. So we had to figure out how to fix them. So basically, I went through a process of trying to refine that. So this is like the V version 0, version 000, version -1. This is like, I'm just attempting it right off the bat. So I changed my settings a little bit. So basically, because I am programming the G-code stuff directly myself using Grasshopper, I have extremely fine control over all the different, like the way the print head moves and the extrusion and all that stuff, the amount that's being extruded and whatnot. So this is the next one. This is like test 0. It looks okay. The inside is nice and clean, you can see. But then we still have the stringing problem out here. So I was like, okay, I had changed some settings. Basically, I had increased the movement speed in between the pillars to try to fix that. Now, you can see it didn't really work. So then an interesting thing happened. This occurred. And you can see basically the first bunch of the print was okay, and then it reached a certain point where it got to the top of this thread section, and it screwed up really bad. So looking at this, you come back to the printer after overnight or something, you see this. This piece had detached from the bed. You can tell because there's like a big blob right there, and that means that the print head was moving. It was trying to print, but this had actually been stuck to the print head. So it was just moving and extruding while this piece was stuck to the head, so it was made this blob. So that usually indicates like bad bed adhesion, or the print got knocked by the head usually, and therefore detached from the bed by being hit. So that was my theory. And then unfortunately you can see like before that happened, the stringing wasn't that much better. Yeah. So you can see like there's these strings here still. So I had basically just kept on trying to refine the movement of the head to fix the stringing, and it wasn't working. So then I did it again. I changed my settings some more to try to get that improved. This is test number 1 or 2. Test 2, yeah, it's still more and more trying, and it looks a little better maybe, but still plenty stringy. So I was getting kind of worried by this point. I did it again. This one I thought was good, and then this is interesting. The first layer looks okay, the first like section, and the second one looks like still not so nice. So at this point I was kind of perplexed. I was like, oh, what's going on? I don't understand. So then I had done these two sort of somewhat better tests. It didn't have that big problem. Then I did this test, right? And I think at this point I had realized, oh, I think maybe the extrusion amount on these pillars is too much. And then I lowered that, and it turned out that was helping the stringing quite a lot. So I was like, okay, maybe that's the problem. But of course, while I was doing this, I found this other much larger problem that was screwing up the print every time once it got to the certain height. So basically, this section here, if you look on the bottom, this is a custom thread. This is like a thread here on the inside that's used to assemble the lamp. And so all these parts are, programmed in, and then, yeah. And so basically, it turns out that I don't know if you can see, like, up inside there, maybe I'll show you on the, oh, you can't see it because that's what I changed. Oh, yeah. So this is what I actually fixed. So you see how this one, it has these strings here that are going across, like chords? That's like an extra layer of this. Basically, I have this thread section, and the thread is embedded in this lattice. And I have created a method of like placing objects, like placing other pieces into these lattices that I am quite proud of because it makes these things modular, and you can like do all sorts of weird shit that I haven't even scratched the surface of how to experiment with yet. But I saw that these extra pieces here were basically, I have this layer. I have what I call an interference layer in between the object, which is the thread section, and the lattice itself. So I have like a layer that gets more and more dense, basically to create like a floor for when it when it's transitioning between the lattice and the object or the thread section. You can actually see it inside there. If you look, you see how it's like a much denser kind of lattice thing inside the gap here, inside these holes. It's that section that I'm talking about. It's like an interference little layer that I invented to interface between objects and the lattice. So that layer has outlines that are there just to cover it up. But I actually, the way I made that layer, I thought it was really cool looking. And because it's like, it gets denser and denser and stuff. So I was like, oh, I should just take this off. Why do I even have this outline to hide it? It's not structural, it doesn't matter. So I took it off. Turns out that when I programmed that into my grasshopper thing, I had accidentally told it to go back and basically repeat the first layer of that interference layer. So this is the interference part, but it's all fucked up because it's all messed up because it is basically, it turns out that it was repeating the first layer again. So if you know anything about 3D printing, basically the way it works is it starts from the bottom and goes up to the top, right? So this is extremely dangerous. If you are programming your own printer using G-code and ignoring a slicer, because a slicer will never do this to you, you run the risk of badly damaging your printer and potentially burning down your house or studio. So I was doing a mistake that badly. I had actually made a really bad mistake when I was reprogramming my grasshopper to take out that little inside layer and the outline. And so it was making the first layer the interference pattern, and then going to the next layer, making the next layer, and then going back and trying to make that first layer again, and then making like the third layer. It was trying to make the first layer each time it made an interference layer. So it was doing this. It was like going up, 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 and then it started going like that. But meanwhile, the rest of the print is completed, or is in progress. So it's also getting higher, and the place where it's trying to print has also been built up, and so it's trying to dig back down into the part it's already printed again. That's why this is all dense. So that was kind of the end clue, was that this does not look right. Like, this is way too dense. I should have figured it out the first time or two, and I had a suspicion, but it didn't make any. It didn't occur to me. I forgot about that. I had changed that outline, so I didn't think there was no reason in my head why it was messing up, because the first one worked just fine. I forgot that I had reprogrammed that outline section, and so it was making this thing, and it was grinding back down into the print. Yeah, very dangerous. So that was a weird process of prototyping that it turns out as I was trying to improve my thing, I wound up breaking the code in a way that was in fact extremely dangerous. I was very lucky that these test prints were only designed to stop like right here. If they had kept going, it would just get worse and worse and worse, of course, and like just build up a big blob of what we call spaghetti. Yeah, but then meanwhile, luckily, I did actually. If you look at the stringing, it's much better than it was at the beginning, right? So throughout that process, I actually managed to do the prototyping while realizing that this part was broken. So then the last test print still looked like this. This is like test 4 or something. And this was actually quite optimistic because I was like, oh, I still have this problem. I hadn't realized why yet. This is the one that made me realize, okay, this is what's wrong. But then if you look at the actual lattice itself, it's quite nice. If you can ignore these like the dangly bits on the bottom here, the quality of the lattice and the pillars and the clarity and the stringing is like nearly perfect. So we had the successful round of prototyping that resulted in a very nice lattice. So after all that, I finally realized the problem. I fixed it. We have this piece. This is the new pendant. I think I'm going to call this an orb. It's actually meant to be like a disco ball, but I think I'm going to do a different one that's more like a disco ball. It's more like a grid on the outside, so it's more reminiscent of a disco ball. This is like an orb. This is some crazy, really nuts stuff, right? You can see this is the start where it was prototyping. Quintessence. Yeah, but this one, hilariously enough, and actually not hilarious at all, I had done a similar thing for the top here, and I'm trying to remember exactly why this happened. But basically, it was because of sectioning. So basically, this huge print like this is not huge. I can go even bigger, but like this is quite a large print. And in fact, because I'm making this G code out of Grasshopper. Grasshopper is an extremely memory inefficient process program to be using to do this. I eventually hope to reprogram my stuff in C++, which is what Grasshopper runs in anyway. And hopefully if I do that, it'll be a lot more efficient for doing it. But point being, when I do this G-code stuff on my computer, I have to chunk it out into chunks because it runs out of RAM. It's actually super RAM intensive. The memory is the limiting factor. It's not the processor. Processor takes a little while, 10 minutes or something. But it's actually the RAM that's the limiting factor. So I actually had to chunk it out. This one is in 3 chunks. Chunk, chunk, chunk. And when I had basically added an extra... I had formalized my chunking process, and I had added a retraction move in between the chunks. And basically, I had done almost the nearly identical thing, right? It was accidentally repeating the first layer. So the very top of the print, it actually, because of the what I did to make that extra retraction move, it tried to go back down to like the third, to the beginning of the third chunk. So like 2/3 of the way up the height. And so the print head actually crashed down into the piece, caused this giant nasty blob, and then was probably just jamming there for 5 minutes while it was trying to make that last layer. So I came back with it was actually the sock, we call the rubber piece that protects the hot end. The sock was like stuck on here. I have a picture for that. We should add it. Yeah, and I was just like, damn, that's really, really bad. But thankfully, the printer is very strong. Printer came out just fine. That was not by no means guaranteed. I had to be really freaked out and like clean off the hot end a whole bunch and put the sock back on and like turn it back on carefully and be like make sure test all the motors and everything. Because when that happens, you can burn out a motor really easily. Not to mention when this sort of thing happens, you can damage your hot end too, of course. But it's the Voron V2.4, very, very strong machine. Highly recommend if you have the guts to build your own printer. Yeah, so that's our adventure. We will be debuting this lamp very soon and you can, by the way, no stringing at all. That was the final result of this whole damn process, is that like you see how nice this is. This is straight off the printer. I didn't even use the heat gun on this because it's a lattice. The heat gun, ideally don't really want to use it because it can melt it very fast. Yeah, so that was my adventure over Christmas and New Year's and whatnot, and the holiday season, Hanukkah. Um, yeah, hope you enjoyed this informative video of the very sloppy and somewhat dangerous. Oh yeah, and then I found out that you can't use incandescent lights for this. I think if we're dedicated to using PLA, polylactic acid, for our prints because it's a lot more sustainable than regular plastic, and it is made from cornstarch, and it's technically technically biodegradable in high heat, like industrial biodegradable settings. But yeah, it turns out that PLA, of course, has a much lower melting point than than other more heavy duty plastics. So, ta-da! If you buy a pendant light, do not use an incandescent light bulb. Of course, we will put this on the website. But yeah, found that out the hard way because I was using a colored light. This really old style light bulb I just found on the street over here. I mean, in a little shop. And yeah, and I looked back at a few 2 hours later, and this thing was like melted off the the cord, and I was like, oh damn! I had to go take it down and all that. So, yep. Don't use incandescent lights on PLA, and don't ever, if you're doing the G-code programming, make sure it does not destroy your machine. Okay, sorry, I just found this one. I forgot. So basically, this was the last prototype. This was the one that was like successful enough where I was like, okay, I'm gonna make the big one. Yeah, so you can see basically this is what it's supposed to look like. It was this layer here in the middle. You see how there was the outline layer for this piece right here that I was talking about. This outline covering up this nice little pattern here. That's the thing I removed that messed up the thing that caused the big problem. So this is what it's supposed to look like. It's like getting denser and denser as you go back down toward the thread object. And then you can see the stringing is like quite nice also. Yeah, so I just wanted to share that real quick because that's kind of important. Cheers. This has been Jeffrey with Quintessence.